Alright, let me not get waxed.
Don't worry, it's foam.
Hey everyone, FusedVR coming at ya.
Hassan here.
And so, yeah, you can see this already in Unity, but we're playing baseball, and I'm definitely gonna get whacked. So this bat used to be green.
Yeah.
And then Hassan did something.
It
so
destroyed some lives of some virtual baseballs. Now it's called the FusedVR Reality Enforcer.
Yeah.
It's our go-to weapon of choice.
Alright, so we're going to show you how to build this. If you want to follow along, there's a link in the description to get the GitHub project. And then after the stream, we'll probably go for about 30 or so minutes, and then we're going to get Emre from Magic Leap. So if you have any questions, feel free to hit him up. And with that, let's just kind of dive right into this.
Yeah, totally. So this is going to be an exciting project, everybody. And FuseMan will be in the chat. We have Ghoster there too. Just want to give a quick shout out to Ghoster. He's our modeler and resident artist on our team. He created not this physical bat, but the virtual bat that you see in the scene. Pretty much anything that we have that ever looks good is from Ghoster. Alright, so today we got a few things to talk about. First of all, setting up the Vive Tracker, and then after that, on the Unity side, it's actually, in terms of the code, I mean, we've done a lot more complicated stuff on other streams, so I'll just give a quick walkthrough of how we configured the physics settings for hitting the bat. The bigger problem is that we ran into some constraints that we're going to talk about for Unity's physics. So let's get started. As always, again, we're going to have all of this stuff on GitHub so you can check out the project, but make sure that you have the SteamVR plugin from the asset store, so you can find that on the asset store. Let me show that really quick. Let's see. Asset store, and then if you're tuning in for the first time, you find that here, so the SteamVR plugin, and then once you have that downloaded into your project, you want to set your camera rig into Unity. So after that, the next step that we did that was pretty important was setting up the Vive Tracker. So what we did was we created this child object under the camera rig. We called it bat because we're using a bat, and we added the SteamVR tracked object to it. Now the index is set to HMD. I think that it resets that when we hit play. Let's check that out. Yeah, so it sets it to device 5 because we have 5 different devices. We have our HMD, the 2 base stations, and the 2 controllers. I think that if you want to use your tracker without the controllers, you can just set the index to whatever it would be. Might be device 3 if you're not using any controllers, or maybe device 4 if you're using just one. So the other key point to note is that there's a small USB that you need to use for your Vive Tracker. So I'll pull it out right here. It's this one. So we just have this plugged into our computer. And then on the SteamVR side, once you pull open SteamVR, in this little window right here, you can just right click, hit pair controller, and then you'll get a prompt. We don't have it right now because we already have everything set up, but you'll get a prompt to press the pair button on your tracker. And what you would do is, we have it kind of covered in tape, but if you just hold down the triangle logo that's on the tracker, it'll take time to pair. And we found that it pairs more quickly when you put it next to your headset. So that's the basic overview of how we got everything set with the Vive Tracker. The last step was to go into the camera rig, and in objects, change, by default this will be 0, but we just changed it to 1 so that we could track an extra object, and we dragged that object with this tracked object script on it into this outlet. So once we did that, we actually had all of our tracking already set for us. So that is tracking this game object, and then as a child of that, we set a model. That model was the baseball bat that Abdo created. So let's check this out in action, make sure that everything's still working. So here I have my bat. I'm going to take some swings. There goes that ball. That one was not a good hit. I can bunt that one. That was actually a pretty good shot. I think that was the best one that I've ever gotten. So now let's jump into the physics of how all of this is working. So in our scene, we have a mostly to scale baseball diamond. I actually made it a little bit smaller because otherwise I wouldn't ever be able to hit a home run. But at the far end of it, we have this pitcher bot. Inside of it, we have this launch point game object. And what this is doing is pretty simple. We have a spawn ball script. Let me open that up. And what this is handling is every 3 seconds, it's going to toss a ball, which in our case is just a simple sphere. The one interesting thing that we added into this is some potential randomness. So I have this launch angle, and that's because we can make it so that our pitches aren't all in a straight line. As is right now, they actually are all in a straight line, so they're all going to the same spot. But if you want to introduce some randomness, you just have to tweak this launch angle. So let's talk about how this all works. So when this initializes, we start this coroutine pitch, and you can see here that you can configure the time between pitches. And for every pitch, we get a launch direction. So for the launch direction, what we're doing is we rotate around the y-axis by 180. We're rotating around the z-axis by a random number between 0 and 180. And then we finally rotate by the x-axis by an angle that we specify. So the effect that that gets us is that we point the launcher towards the player by rotating on the y-axis. Then we tweak the z-axis, and then when we actually change the x-axis, it just changes the angle of the launch. So that's how we get the random pitches. So I can show you that working if I set launch angle to, say, 10. Now you probably don't want to do this because this is a long distance, so that angle of 10 ends up creating a really wild pitch that there's no way your player is going to hit. So let's check that out. So there's one of them. So we can see that some of these are hitting the ground before they even get to the player. That one was really high. And some of them, yeah, that one was super high. So again, you can configure that launch angle in the launch point to change how the spheres are fired off. So next, let's go into what these spheres are doing. They're handling the action of the collision. So we have those saved as a prefab. Let me go into that. And the first thing that it's doing is it's just applying a force via an impulse so that the ball flies towards the player. And we've turned off gravity, at least until we have a hit. We detect the hit with this onCollisionEnter method, and we only want to run all of the stuff in this if we're hitting the bat. When we hit the floor, we don't want to do anything special. So on the velocity of this ball, when we hit it, we're setting it to 0 so that we can take over with all of the physics effects that we're going to add from the bat hitting it. We also have an audio source configured, so we play that. And another important point that we have is that when you're swinging really fast, and it's possible to collide with this ball multiple times. So we're using physics.ignoreCollision to make it so that the bat only hits the ball once. It doesn't keep going through it and collide with it multiple times. Then what we do is we take over the physics of the ball and apply the right force so that we can get an effect of hopefully a home run if we can hit one. But there are some problems with this that we'll talk about. So the first thing that we do is we get this force multiplier. This is something that I used just like tweaking and coming up with different ways to try to keep track of pretty much how much force should we apply to this ball when we hit it. If we don't apply any sort of special force to it, then we're going to get a very lame hit. It's not going to go flying off in the direction that we want it to. So I was tweaking with some different ways of getting the right type of a force, and this is the best thing that I came up with. But the thing with Unity is that the physics system, and this is true pretty much with most game engines, is it's not perfect. It's all based on approximations. So you might want to tweak how we get the force that the bat imparts on the baseball, depending on how easy or how hard you want your game to be. But this is something that I found that worked pretty well. It's not perfect, as I mentioned before. So then the last thing that we do for this part is we get the direction via this line, and then we actually apply that force to the rigid body on this object, and then we turn the gravity on so that we can get a nice arc effect. I also have this trail renderer attached, and I turn on the trail renderer once we hit the ball so that we can see the arc of it. So I'm going to jump in, and I'm going to just give this a few tries, and you'll be able to see how this all works out. Last point that I want to point out is that that audio source for playing when we hit, we get that nice pop sound, is on the sphere prefab. So that's right here, hit. And then I also configured a miss zone behind the player. So if you shank the ball and it flies behind you, or if you completely whiff it and get a strike, this is a trigger zone so that when the ball hits it, we throw this error noise. All right, so let's try to take a few shots at this. So here's my bat. Shanked that one a little bit. That was not a good hit. Totally missed that one, I think. Not a good hit either. Oh, man. I just want to get one good one. I keep shanking these. That was okay. So as you can see, we're not getting the right force on all of these hits. Yep. Oh, I see. Yeah, I changed the scene view. This is why it's good to have two people here. Alright, so now you guys can see. Anyways, that was me warming up. You probably didn't want to see how that looked. So I think you'll be able to see this better. Yeah, so what to look for here is that we can't get a perfect physics collision on this. So that one was bad. That one stopped too short. And you might be able to notice that what's happening is my bat is really jittering around as I swing, because it's moving super fast, and I don't think that there's enough time from the tests that I ran for the Vive Tracker to actually communicate really well with Unity when it's moving this fast. So I'll try to take some slower swings. So that was better. Now the bat's jittering all over the place from me just whacking it. Having some tracking issues. So that was a pretty good one. Alright, I'll end on that one. That one was pretty satisfying, even though it wasn't a true baseball. Oh, what?
Side angle.
What is a side angle?
Like, this is like behind the ear.
Oh, okay.
The ball actually comes towards you.
Like a profile view of it all?
So like rotate to the left, I guess.
Rotate to the left.
Oh, I can't see it here.
Alright, so we got a request in the live stream to get a different angle on me completely being
like
terrible at baseball. Alright, so here we go. Let's see, I might make a few changes to this. So, first of all, I'm going to make the collider on this sphere bigger. And that will make the collision detection a little less rough. And I think that should be okay. But like I said before, a lot of this project comes down to just Unity physics. So if you want to copy it and turn it into a game, expect to spend a lot of time tweaking it for what you want. Alright, so I think this is the angle you're asking for. Gotta get my bat back. Shank to that one. So I'm definitely having tracking issues. As you can see, I'm holding the bat steady right now, but it's leaving my hand because I'm moving it so fast. And the tracker's not able to update that quickly. That time the bat just completely flew off in the distance. Alright, do you have any questions before I jump into more custom stuff?
Yes. So I think you covered this, but Roland asked, like, how do you ensure making sure you detect a hit at high speeds?
Mm-hmm.
Which I think you covered.
Yeah, good point. So I kind of talked about it, but what I was going to do next is talk about what I actually did in Editor to make some of this stuff work. So it's a really good question from Roland. He asked, how can we detect these high-speed collisions? It's definitely a problem in Unity. I mean, like I said earlier, most of the physics is just an approximation, so you don't always get like really high fidelity collisions on your objects. So let's look at a few examples of what we did to get around that and still get some decent collisions. So the first thing is that on the bat and the sphere, the ball that's flying towards us, we want to configure those to continuously be checking for collisions. So the way you do that is on their rigid bodies, which they need to register collisions with each other, change collision detection to continuous dynamic rather than discrete. This gives you a lot more updates on when collisions are being checked for. And then on the objects that fast-moving colliders are going to hit, such as the floor, let me select that, change their rigid bodies to continuous. And this is just advice that we got from the Unity documentation. If you look up rigid body and collision detection, the advice that they give there is for objects that are hit by high-speed objects, their collision detection should be continuous. For fast-moving objects, their collision detection should be continuous dynamic. And then for things that don't really have complicated physics or need lots of updates and checks, you can just use discrete, which is the default. Now, one thing that I tried to do to help out on these objects was I set the interpolation from none to interpolate. That's something that you can do to get even more fidelity, but it didn't really help out. So you could try that yourself, but again, on our side, we still had some of those issues where the bat doesn't hit the sphere perfectly. But at least by doing this, we can get some solid collisions. So the last point that I configured in the editor is that the mass of the bat is really high, and then the mass of the ball is really small. So just remember that if you end up changing the mass of one of them, you're probably going to have to change the mass of the other, and you'll also have to tweak the forces that you apply via scripting. Physics in Unity, there's a lot of moving parts, so definitely expect lots of tweaking. Any other questions?
Any other questions?
Yeah.
There was one question on what happens. Could you use two trackers to get a higher fidelity tracking? Like one, I guess, bottom, one on the top.
Yeah, so we haven't tried that. The question is, could we use two trackers to get higher fidelity of tracking? So, that's a good question. We haven't tried it. We only have one tracker. If we did, then what I would expect is that the bat won't, like, jitter as much as it does as we swing. Like, we can just lock it between the 2 points. Or if one of them is really faulty, we could just tie it to one of them. But I think that we'll still have issues with this collider might just be moving way faster than Unity can detect collisions. I've never really dived this deep into physics with Unity, but it does seem pretty intuitive that this bat, if you really swing, is moving super fast, and I don't know if Unity is able to catch all of the collisions. So it would help with the bat placement, but I think that we would still have some collision errors. All right, cool. We're about 25 minutes in.
One big request I is enable bullet time.
Bullet time, so slowing it down?
Yeah, so just like go into time and then drop the time scale.
Okay, let's see. So,
it's a good request.
yeah. So that's actually something that I tried. I can just do it really quickly right now. What I'll do is when the ball flies through and gets close enough, I'll slow it down, and then I'll set up a coroutine so that after a certain amount of time, that slowdown gets removed. So I'm gonna duplicate this miss zone. The reason why I'm doing that is I like the collider setup on it already. I'll call it bullet time. Then I'm gonna remove a bunch of these. Oh, it makes me think my miss zone. Alright, so here's bullet time. Still have this box collider, it's a trigger. Let's move it forward. So we'll move it in front of the player, maybe about, let's see. So once it starts to get close to the batting zone, that's where we'll put this thing. So this is about 5 meters in front of the player. And then we'll call this bullet time. Fine. We can stick to the FPS lingo. Bullet time. And what we want to do is run an on trigger enter in here. So when something enters this trigger, then we are going to detect, we'll toggle on bullet time, and then after a set amount of time, we'll turn it off. So let me look up the function call for that. I have it set up in miss already. So it's on trigger enter, collider other. And we want to just do a quick check if game object or other. We want to make sure that that other game object that actually hit this is a ball. And we also want to make sure that we don't trigger this again when the ball goes through the trigger on the way back. So we're going to have to set those up to ignore collisions. So if the name, or actually I'll just tag it with baseball. This is pretty hacky, I'm just doing it for the sake of speed. I'm going to tag all of the prefabs with this baseball tag. So I'll do that right now. So I can go into tags, add tag. Oh, I can actually just tag it with projectile since that's already there. I prefer that. So I'm going to tag this sphere, or these pitched balls, as projectile. And then now, if the tag is projectile, we know that it's a ball that has passed through this. So what we'll do is we'll set time scale to, let's just try out halftime. Then we'll start a coroutine. Yeah, I got it. Yeah, so if anybody's just checking in, Vasant and I just solved the same bug at different times. Alright, so what we'll do here is we'll just wait for like, oh, this is gonna be weird though because we're changing time. Alright, well, we'll see how this works. And then after that wait, we'll set the time scale back to normal.
You can use, are you using wait time or wait real time?
I'm using wait for seconds.
Do you wait for real time seconds?
Wait for seconds, real time. Oh, nice, using unscaled time. Great.
It's so convenient.
So then after that, this should be 0.5f. We also need to set up for these, we don't want the ball to hit it on its way out and then cause another collision. So I'm going to try to use this physics ignore collision there, and we'll see if it works. So here we want collider.GameObject. So this is going to be the sphere. Oh, other. So this is the ball, and now we need to get the collider on this, which is a box collider. All right, let's see how this works. Just to reiterate, the ball is going to hit this trigger. We trigger this on trigger enter function. We make sure that it was a projectile that hit. We set the time scale to half. We start a coroutine that's going to return us to the normal time after 2 seconds unscaled. Then we also set to ignore the collision between the ball and the trigger that it just entered, because we don't want the time scale to also change when the ball's going back. So let's give this a shot. Make sure everything's set there. All right, here we go. Oh, you guys aren't going to be able to see that. I can already see it slowing down a little. Reset this. Not getting my... Oh, this might be off. Alright, so here comes the ball. It did slow down a little bit. We might want to slow that down more. I don't even think that you guys can tell that that's slowing down. So let's change that half to 0.25. So now we're running at a quarter of the time. Hopefully this is more noticeable. Here it comes. Yeah, definitely slowed down that time. I'm still shanking it though. I didn't play baseball ever. That time the slowdown actually psyched me out. It's easy to swing too early now. Oh gosh, it's actually pretty tricky. I need to wait for it. Alright, so here, what we can do now is let's just boost the force that we're applying to this object. So again, I have that in get bat force. We have it at 30 right now. Let's turn it up to 50. So we're almost doubling it. And this will be the last thing that we test out before we try to switch over to the creator chat. So here comes the ball. Ah, not a good hit. That was a solid one. I missed it there. This was a good suggestion. Who takes credit for this?
That would be Roland.
Well, Roland, you came up with a good idea. I had tried out the time scale before, but never tried toggling it between slowed down time and real time. So that's actually a great suggestion from the live stream chat. We'll be integrating that. We already have, and we'll push it to GitHub so you can find it in the project. But that's about it. So what we've talked about is how do you get set up with Vive pucks, or Vive trackers, as they're officially known, with our trusty FusedVR reality enforcer. We've gone through some physics tweaks. We've talked about what makes it difficult to use trackers when physics is choppy or when you're moving really quickly. But we also talked about some ways that you can configure your scene to detect really high-speed collisions. Specifically, go into your rigid bodies and be sure to change the collision detection to continuous dynamic for the fast-moving objects and continuous for things that get hit by those fast-moving objects. So that's about it. Unless there are any questions left, which I don't see, then we're just going to take a break for a while. And if you're on the live stream, stay tuned. We're planning on having a creator chat starting pretty soon. And if you're just tuning in online and watching this after the fact, then check out the rest of our channel. We have these things called creator chats where we interview individuals who are working on tons of cool stuff in the VR and the AR space.
Good to be here.
All right.
And so, yeah, if you haven't, go ahead and like the video. That helps us out a ton. Or you can follow us on social media because you'll see teasers and see things about who's coming on. So definitely take a look out for that. And I think that pretty much does it. So this has been Fuse, man.
I'm Hassan, and we got Emre here.
And we're signing out.
Work to do that, Hassan.